Part of today's lesson is how to use the Pascal's triangle. We're going to learn three things: how to construct it, two, the relationship between combinations and Pascal's triangle, and three, using Pascal's triangle to construct the binomial theorem. So let's get started. How to make Pascal's triangle? Well, it starts with a 1 at the top. And then the next line will start with a 1, nothing in the middle, and then end with a 1. Now continuing, you start with a 1, and then you do 1 plus 1, which is 2, and then you end with a 1. So you add the two numbers above it. Start with a 1, 1 plus 2 is 3, 2 plus 1 is 3, end with a 1. Next, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. And last one I could fit on here is 1, 6, 15, 20, 15, 6, and 1. And it would continue. So you always start and end with a 1, and you add the two numbers above it. Next, we're going to take a look at how the relationship between combinations and Pascal's triangle can be used. First, you need to understand that the first row is represented by 0. So we don't start by saying 1. We say that, okay, this is row 0. So therefore, this is row 1, row 2, row 3, row 4, and so on. So it's actually the second number in always tells you what row it is. Here's row 5, and there's row 6. So we're going to be counting rows, and we're going to be counting columns. And when you start counting columns, you always start with 0. So when you want to start, let's look at this here. This is row 3, but this is column 0. This is column 1, 2, 3. So once again, you start counting with 0 for the rows and columns. So now that you know how to count the rows and columns, how is this related to combinations? Well, remember, combinations, NCR. Now another way you can write this is with parentheses, and then you have the N value on the top, R value on the bottom. There's no fraction symbol. So N on the top, R on the bottom, and they're small. So you count. If we want to find 3 combination 2, which you would write as 3, 2, you would count 3, the N represents the rows, and the R represents the columns. Alright, so let's go. 3, you count as 1, 2, you start as 0. So here's 0, 1, 2, 3, and now you start counting in with the columns, starting with 0. 0, 1, 2. This here value represents 3 combination 2, which is 3. Let's try it again. Okay, next, let's try to find 5 combination 0. Okay. So here we start counting our rows, and we start with 0. 0, 1, 2, 3, 4, 5. And then we start counting in 0. And here is 0. And that represents the columns. Okay, so 5 combination 0 equals 1. Now, that one's pretty simple, but let's list the rest of these with the 5th row. So again, always start with 0. So this here is 5, 0. Here, this is 5, 1. Right? So 5, 1 is 5. 5, 2 is 10. 5, 3, the value is 10. 5, 4, value is 5. And 5, 5 is 1. So there's all the positions listed in terms of combination. Now, what is the combination for this number here? Well, in order to get this particular 4, you have to find the n. And remember, the n means the rows. Start with 0. 0, 1, 2, 3, 4. So it's 4 combination what? Start with 0 on the left side. 0, 1, 2, 3. So 4 combination 3 represents the 4. How about this here 20? Shortcut, it's the 6th row. The second number in tells you the number row. So that is 6 combination 0, 1, 2, 3. 6 combination 3, the value is 20. And again, remember, you could write this with parentheses at 6, 3. Whoops. We are now going to need to use the combinations for the binomial theorem. So that's the last part of this lesson. Okay, so now here's the binomial theorem. The first row, remember, means row 1. Row 0. The first row means row 0. So when we write x plus y to the 0 power, that equals 1. And there's the 1. Okay, now moving forward, second row is the first power. So x plus y to the first power is x plus y. Here we are with row 2. X plus y to the second power is x squared plus 2xy plus y squared. Moving on to the third, it is x plus y cubed. That is x cubed plus 3 x squared y plus 3x y squared plus y cubed. The pattern would continue. So the question is, how does the Pascal's triangle relate to when we multiply out these polynomials? And the answer is, one is that the coefficients match up with the numbers in Pascal's triangle. So the 0 row is just 1. But here, the second row 1 Row 1 has the numbers 1 and 1. And look, it's 1x, 1y. Row 2, and then 2, we have 1, 2, 1. 1, 2, 1. And then we have 1, 3, 3, 1. 1, 3, 3, 1. And it will continue. So that's the first thing. The second thing are these exponents. So see how the x is the first exponent? So what we have to do is, let's do the next one. We're going to need more room, so we're going to work down here. Alright, so my first coefficient is 1, and then it's going to be x. Now this represents x plus y to the 4th power. So we're going to start with x to the 4th plus 4. The first term, which is x, is going to go down. So it's going to be x cubed, and then the second term, which is y, is going to come up. So it's 4x cubed y. Plus 6, x goes down, oh, come on, 2, and the y goes up, plus 4, x, y cubed, plus y to the 4th. So you use the coefficients, and you have to remember that the exponents go up and they go down. And the other key thing is, if you add the exponents together in each term, they would always equal what the power is. So for example, we're raising it to the 4th. So here's just 4. 3 plus 1 is 4. 2 and 2 is 4. 1 and 3, and then there's the 4. So we use it for coefficients, and we use it for, and you have to remember the powers, the first term goes down as the second term starts to go up. And the exponents would always equal the number of what the binomial is being raised to. So now let's apply this to other larger numbers, and we will also use combinations. Okay, so let's multiply 2x minus 3 to the 4th. Now what does that mean? 2x minus 3 times 2x minus 3 times 2x minus 3 times 2x minus 3. So we would distribute and combine like terms and do that about 3 times. So instead of doing that, here's where the binomial theorem can be used quite easily. So forget multiplying all that out. Okay, so we know the power is to the 4th power. So once again, we are using, we are going to be using the 4th row. Remember, this is 0, 1, 2, 3. Here's our 4th row. 1, 4, 6, 4, 1. Okay, now we could have, you could either draw out Pascal's triangle, 1, 1, 1, 1, 2, 1. And here we have the numbers that we need in the 4th row. Or you can use combinations. So the first term starts with the 1, but that position is for combination 0. And this here is for combination 1. Here we have 4 combination 2, 4 combination 3, and 4 combination 4. So to expand this, we would first have 4 combination 0. And if you haven't memorized it's 1, they don't even have to write 4 combination 0. Now you have to be careful for the rest of this. 2x is the first term, so that's going to be all of that to the 4th power, as negative 3 is to the to the 0 power. Now we do plus. Now we do 4 combination 1 And then 2x will go down to the third power. And negative 3 would be to the first power, because 3 plus 1 is 4. Plus, I'm going to erase this work so we have some room. Okay, so then we have plus 4 combination 2 of 2x to the second power, negative 3, make sure it stays in parentheses, to the second power, plus 4, 3, 2x to the first, negative 3 cubed, and lastly, 4 combination 4 of 2x to the 0, and negative 3 in parentheses to the fourth power. Now, let's simplify. 4 combination 0 is 1, and then 2x to the fourth is 16x to the fourth, and negative 3 to the 0 is 1. Alright, now we have plus, let's add this. 4 combination 1 is 4. 2x cubed is 8x cubed, and then we have negative 3. Okay, and then we have the next guy, whoops, over here. Let's erase that, this was all that. Okay, so now plus, we have 6, that's 4 combination 2, that value is 6. 2x squared is 4x squared. Negative 3 squared is 9. Moving on. Plus 4 combination 3 is 4. And then we have times 2x times negative 3 cubed is negative 27. Oh, come on, 7. And then the last part, plus 4 combination 4 is 1. And then we have 2x to 0, which is 1, and negative 3 to the fourth is positive 81. So once when you simplify all this, we get our final answer of 16x to the fourth minus 96x cubed plus 216x squared minus 216x plus 81. That's your final answer for 2x minus 3 to the fourth. Now, just a quick recap. You can use combinations, or you can draw out Pascal's triangle, and you could just write those numbers in. Doesn't matter which way you choose, either one is fine. Just remember how to construct Pascal's triangle. Now try these two problems. You're going to expand the binomial. You can use the coefficients from Pascal's triangle, or you can use combinations. Hit pause, and I will reveal the answers in a few seconds. Here are your two answers for example 2 and for example 3.